Okay, so we have a stats professor deciding whether students are registered to vote. She does a sample of 50, so we assume that's random, randomly sampled. From her 700 students, that's our population, and 35 are registered to vote. 95% confidence interval. So we know that X equals 35 that said they were registered to vote of the 50 students who were sampled, and it was a random sample. So P hat is 35 divided by 50. Q hat is that taken from 1. And it's a 95% confidence interval. So Z star is 196. Said it was a random sample of 50 students. 50 is less than 10% of all her students. 35 successes, 15 failures. And that's a 1 proportion Z interval. Conditions are met because random sample, less than 10%, and we had more than 10 failures and 10 successes. So then we do the calculations for it. And we see that confidence interval is P hat plus or minus Z star times the standard error. Standard error is P hat Q hat over N, the square root of, and that's 0.065. Then of course, on the calculator, stat test 1 proportion Z interval, because we named it right here. 35, 50, it's a 95% confidence interval, and calculate. And there's my interval. So 0.573, 0.827. Rounded this up to a 3. So then we are 95% confident. The true proportion of her students registered to vote falls between 57.3% and 82.7%. What does that mean in context? If we do a lot more samples of size 50 of her students, about 95% of the intervals will contain the true proportion of her students registered to vote. What's the probability of that occurring? Confidence intervals have nothing to do with probability. You're going to see that question, ignore it. Probability, don't ignore it. Probability is not part of confidence intervals. And it talks about the Gallup poll, 73% of 18 to 29-year-olds, college student age, registered to vote. Does that 73% from Gallup seem reasonable for her students? Sure, because 73 falls within the interval being 57 to 83 approximately. And 73% falls within that interval. So yeah, that seems reasonable for her students. And then it asks if she knew those numbers, 73 being my P hat, 27 being my Q hat, of her students registered to vote within 4% with a 95% confidence. So margin of error is Z star times standard error. So 0.04 equals my Z star, 0.73, 0.27 over N. We're solving for N. Divide both sides by 1.96. This divided by this is 0.024. 0.73 times 0.27 is 1971. 0.1971. Square both sides to get rid of the radical. Gives us these numbers. Divide 1971 by 0.0042, and I get 473.6 students. Can't have part of a student, round up. 474 students, but that's greater than 10% of our classes, so that number doesn't make sense.